Hello, welcome to my devlog series. I wanted to give an update on the AI system that I've been working on. I've been using the Unreal State Tree, which, if you haven't heard about before, it's pretty cool. If you've ever programmed your own state machine, then it is really intuitive. It is really extremely flexible and there's a few tutorials out there for you to get started. I'm pretty happy using it. In fact, I think I might switch my uh, own state machine that I programmed to the Unreal State Tree because it has all the same functionalities plus a few more. And, you know, at the end of the day, it's just a state machine, so pretty intuitive. You have a enter state, exit state, tick state, but just a lot of extra plugin things that are pretty neat to have. So yeah, so I wanted to talk about the state tree. So I'm currently working on the combat behavior, and I'm trying to get AI that will chase the player and then surround the player in a way that feels like it's a group behavior, organized behavior, not just running at the player. So kind of like Ghost of Tsushima kind of thing. So I wanted to give an update on what I've been doing with this. I have kind of two setups. One is using a mix of a combat director and the Unreal Environment Query System, and a little bit of steering behaviors. Um, but mostly the implementation here is almost purely using the environment query system and a little bit of communication with the combat director. Um, I'm happy enough with how this is looking, but I already started moving away from this setup. So I'll talk about what I achieved here and what's good about it. But like I said, I've already moved into something that's a bit of a mix between this using a combat director, the environment query system, and a little bit of or leaning more heavily into the steering behavior tasks that I implemented for the state tree. So, so I guess I'll start by talking about the combat director. So here's the combat director, and it has these uh, inner circle tokens. So the combat director is going to kind of keep track of targets. There's a map of actors to a vector of attackers, which are also actors, and so it'll keep track of who's being attacked and what group is attacking it. So in this case, the player would be the key of the map, and the attackers would be all the enemies. And the enemies will request um, they'll request inner circle tokens. So if they don't have an inner circle token, they'll be in this surround target behavior where they get to pick some locations and be kind of standing back and not actually get to attack. There's a maximum number of tokens that will be handed out. In this case, it's 3. And so when they're in this surround behavior, they'll be requesting an inner circle token, and when they get it, then they'll go into this engage behavior, and then they'll be in this behavior is where you start asking for attack tokens so that you actually get to attack. So it's the enemies that are in the inner circle that actually get to attack. Of course, when you're playing, you don't know exactly who's in the inner circle, so just based on positioning and animation, you have to figure out if you think an enemy is going to attack you. So I'll show a little bit of the initial of the behavior, how it looks ultimately, and then I'll explain a little bit more about it. So here you see a bunch of enemies. Currently they haven't seen me, and then I'll go up to them and let them see me. And there you see that they all entered this initially they all entered the surround behavior, and then some of them got inner circle tokens, and those went into this engage behavior. So you see that those are closer and highlighted with a red sphere around them, and they're much closer. And so you move around, and those will kind of update based on what the combat director decides who gets the bumped off the list of inner circle tokens and who gets new tokens. And so you see that they surround the enemy in a way that looks nice enough. It looks like a group that's definitely trying to uh, overwhelm the target from all directions. And what's also happening here that you might see when they move is these velocities that are being applied for them to avoid the player and avoid each other, so that when they run past you to a location that's near you, they kind of circle around the player, like they're trying to keep their distance from the player. And so the way this is working is, like I said, when they see the player and they get a target, they initially will try to enter the um, engage target behavior, and they'll get a token. The ones that don't have a token will enter the surround target behavior, and that basically just means moving to your combat location and waiting while you ask for for inner circle tokens. And when you get a token, then you'll get to enter the engage target behavior, which is pretty similar. It also is just moving to your combat location and then waiting to attack. In this case, you start asking for an attack token, which I haven't gotten around to implementing yet. And so, how does approaching the target work? So in behavior trees, you have all these tasks that can be acting at once on the actor. And here you see that I have a behavior that's avoiding the target. So they'll kind of run in circles around the target, around the player, and not actually in a straight line right past him. And then there's this approach target behavior, which you see here is it accesses the director component, which is a component for communicating with the combat director, and then it'll start querying around the target location. It'll start performing this query, which is making sure that there's visibility to the target, that the distance is not too far, not too close, and also there's this dot product test. That's just kind of ensure that you don't pick a location that's very off from your line to the player. That way, you just reduce a little bit of the crossing each other that enemies sometimes do when they're selecting points a little too at random around the target. And so once the query finishes, what you do is you update this move to location, and if as the target moves, if the player moves around and you move too far off of from where you were standing, then the AI will query again over and over, so that you don't get to a location and then realize that the player is now a mile away, and you were never actually chasing him. Another interesting thing to mention is that when my AI selects a move location, they'll put a waypoint there. A waypoint is just a location that the combat director tracks. I think I can show it around here. Yeah. And so when they put a waypoint down, the environment query system has a test to check if there's any waypoints near that location. So we have this test that's minimum distance to waypoints, and what that does is that it allows you to prefer greater distances from other waypoints. So that way, AI will make sure to select locations where another AI is not currently heading to as well. Sometimes you have two AI heading to the same point because they both think that it's a free location that doesn't have any enemies on it. And so that's another interesting little thing that creates this behavior illusion of AI acting together to surround the player. And then another the third part of the behavior is how they don't just run in a straight line. I don't like when an AI is running to a location that's kind of past the player and they'll run right past the player to get to their attack location. It looks very contrived, or it looks dumb. So what I did here is I have this state tree task that will on every tick uh, calculate the location, the vector of the actor to the avoid actor, the actor that it wants to avoid, and it'll calculate a distance and an avoid direction, and basically it's going to end up calculating a velocity away from that um, actor, and it'll apply it. But ultimately, all this is just applying an arrow, a vector that points from the actor that you're trying to avoid uh, toward you, toward the AI, and then it adds a little input vector in that direction. Um, this is the way I was doing this before. In the next video, I'll talk about a little bit what I've done since then, which is this is a little bit like inspired by steering behaviors, but since then I've actually programmed a much more direct actual steering behavior system where there's avoidance and that kind of thing. And like I said, that's mixed with the environment query system. But here, there's just a little flavor of combat of steering behaviors uh, in this system. And if you want to see that again, you can see when they run. Yeah, you see that guy ran past the player, but avoided him as he came close. And there you can see that AI will select locations that are kind of nicely surrounding the player, and it comes across as fairly organized. Obviously, it would look better with better animation and if they actually were facing the target, but I'm not worrying too much about that kind of thing right now. But yeah, I think this shows well enough what I achieved using just the environment query system. I think there's a stuff that looks more natural that can be achieved with steering behaviors. Um, mixing kind of simple behaviors can start to look like very organized behavior from a group, as well as like the same idea as what's being implemented here of having a surround behavior that's separate from an engage behavior, or an outer circle versus an inner circle. Um, that's, I think, what makes the AI seem intelligent, when you see that some enemies are holding back and allowing others to attack, and then one enemy will decide to, quote unquote, decide to stop attacking, and another one will come and take its place. I think when you mix that with a nice smooth movement system like what you get from steering behaviors, then you kind of can end up with the best of both worlds. So that's what I'm working on currently, and that's what I hope I'll have an update for in the next couple of weeks. So yeah, I just wanted to show this. This was attempt A good enough, but not good enough. I think I can do something a little bit better. And we'll see next time. All right. Cheers.